This lesson is for Advanced Algebra, Lesson 5.4, Solving Systems Using Linear Combination. Linear combination, remember, is a certain way that a linear equation looks. Typically, if an equation looks like ax plus by equals c, that's considered a linear combination situation. The x and the y are together on the same side of the equal sign, and the a, b, and c just represent numbers. So if you have a system that has this type of setup for both of the equations, you're going to look for opposites and then add vertically to solve. Remember that when you're trying to solve a system, one of your goals is to try to eliminate one of the variables. So we're going to start with this nice easy example. Clearly these are both in linear combination form, ax plus by equals c, with one slight exception on this one. This one has the x and the y together on the same side, but they're not quite in the right order that we would like. So we can just use the commutative property here and just move these around. So the top equation is going to stay put. It's going to stay the way that it is. And I'm just going to rearrange the bottom equation so that the x is first and the y is second. So I'm just going to move the 5x and then the 6y around. Now if I look vertically, I'm going to look for anything that has opposites. So right here you can see that the negative 5x and the 5x are indeed opposites of each other. So I'm going to add the two equations vertically. When I do that, the x's will cancel. Negative 5x plus positive 5x makes 0x. 0 times x is 0. Then I'll add vertically for everything else that I see. 3y plus 6y is 9y. And 11 plus 7 is 18. Now I know most students can probably finish this without a whole lot of algebra effort. Most kids know that 9 times 2 is 18. But just for the sake of example, let's talk about what we would do mathematically to both sides even if we didn't know what the y value was. Since the 9 and the y are next to each other, we would divide to get that y isolated. So the 9's there make a 1, so we know our answer there is just going to be a 2 for y. The other thing that students want to be careful of here is you're not finished. The y value needs to be plugged into either of the two original equations, and then they'll be able to solve for x. It is okay to go back to one of these two, especially this one since it is the original, but I would recommend avoiding any modified equation to try to find your y. It's just going to be better for you to find it from the original. And again, it doesn't matter which one you choose. I typically just pick the one that is the most convenient and has the smaller amount of numbers, there's smaller values of numbers, and has the least amount of negatives. So I'm just going to plug it into this bottom one here. So I know 6 times 2 is 12, and now I'm going to solve the rest of that equation for x. I'm going to add negative 12 to both sides. If I do that, I get negative 5, divide both sides by 5, so x has to be negative 1. Keep in mind that your answer could be listed in coordinate form, so you could list it as negative 1, 2 that way, or you could list them out separately. I would also recommend checking your answer by plugging in a negative 1 and a 2 here, so we can just do that real quickly. If I do negative 5 times negative 1, I know that that's going to be 5. 3 times 2 is 6. 5 plus 6 is indeed 11, so I know that it checks. So that's the real basic version of what you're going to do if you're using the linear combination method. The problem is not all equations are set up to be this nice. So let's look at what we would do if we don't see opposites when we see that we have linear combination. So if you don't see any opposites, try to find where you could make some opposites by multiplying. So as you look at this system here, 5x minus 6y equals 3 and 2x plus 12y equals 12. 5x and 2x are not opposites, and negative 6y and 12y are also not opposites. But we do have a negative here, so we know that we've got the opposite signs going, even though they're not the opposite value. So what I can do on the top equation is I can multiply by a 2, and that will turn the 6 into a negative 12, which would then be the opposite of what I'm looking for. So I'm going to modify that top equation by multiplying the whole thing by a number. And remember, that number came from me just looking at what I've got here. Another option that I know some kids have asked about is, could you divide by 2 on the bottom equation? And the answer is definitely yes, you could. Typically though, multiplying is a lot easier for kids than it is to divide. So I would recommend always looking for something you can multiply by rather than something you can divide by. But know that dividing would also be appropriate. The other thing that's a difficulty for dividing is sometimes when you divide you end up getting a fraction, and I know most kids like to avoid fractions, which I'll be honest, I typically try to avoid them if I can as well. So it's just easier usually to pick a number that you can multiply by. So that top equation is going to turn into 10x minus 12y equals 6. Bottom equation is going to remain the same. So now when I add vertically, I'm going to get 12x, the y's are going to cancel, and then I get 18. If I divide both sides by 12, I'm going to get 18 twelfths, which reduces 2. Since they're both even, I could divide them both in half. So that's one option. I also know that a common factor here would be 3, so I'm going to divide them both by 3 and see if that helps me at all. If I divide by 3, I'm going to get 6 and 4, and that reduces to 3 halves. So my x is 3 halves. If you want to write it as 1.5 in a mixed number or as 1.5 as a decimal, that's also fine. Those are all equal to each other. I'd recommend though leaving it in fraction form in lowest terms. That's going to be the easiest way to find your other value that you're looking for. Remember, we need to find still what the y value is. If I plug in 3 halves in for x, I'm going to plug it in here because look what happens. 2 times 3 halves plus 12y equals 12. On the 2 and the 3 halves, the 2's are going to cancel out because it's 2 on top, 2 on bottom. So we end up with just 3 plus 12y equals 12. Subtract 3 from both sides, divide by 12. So my y is going to be 9 twelfths, which reduces, if I divide them both by 3, that's going to be 3 fourths. I also want to point out back here that both of these could have been divided by 6 as well, so you could have gotten to your 3 halves much faster if you had picked the largest common multiple, which would have been a 6. But I was trying to illustrate some other versions of how to reduce that. Divided them both by 2 would have worked, and divided them both by 3 works. Always try to pick the biggest, which would have been the 6. So now remember that we can put our answers together in coordinate form if we choose, or we can leave them separately like we did. So if you don't see any opposites, remember, try to make some opposites. Let's say that we decided not to choose 2 here. Maybe we wanted to eliminate the x's. Another option here would have been to double the top, and then we also could have multiplied the bottom by like -5, for example. That way the 5x and the 2x would have become opposites of 10 and 10x and -10x. And then we would have canceled out the x's first to get our answer. So know that there's other options here. You don't always have to choose just one method. Typically there are multiple methods involved, or multiple options multiple avenues you could take to try to get to your answer. There are some examples in the book that have students work with 3 variables. I'm not going to make students learn this, but I do want to point it out here in the video, as I said in class that I would explain a little bit more in detail. You can only do 2 things at once. So if you're working with a situation like this system where you have 3 variables, you're going to eliminate one of the variables in 2 of the equations and then again in the other 2. Then eliminate an additional variable in the 2 new equations and solve. So what I do on this next part is just explain and walk you through how I solved this system by eliminating 2 things at a time. So here's my original system without the bracket. I decided since this b has a negative in front of it that I would use that as the first thing that I would eliminate. So I took the top equation and the bottom equation, and I decided to first multiply the middle equation by 4. When I did that, I got this equation down here with the dark blue. The top equation stayed the same. Then when I added vertically, the b's canceled and I ended up with 11a plus 17c equals 162. Then I went back to the original system, used the same middle equation, this time multiplying by 3 to get 6a minus 3b plus 9c equals 105, kept the bottom equation the same, added those vertically, and I got 13a plus 8c equals 131. Now I'm going to take those two equations and put them together in a brand new system. Now I need to eliminate either the a's or the c's. I chose to eliminate the a's by multiplying the top row by a negative and the bottom by a 13. What that does is make those both the same number, with one being negative and one being positive. Know that that negative could have been with the 13, I just decided to put it with the top number. I put it with the top number because this number was smaller than that, so then I knew I'd have a positive result. So I multiplied both equations this time to try to eliminate the a's. When I added vertically here, I got 133c equals 665. I was able to divide that on both sides by 133 to get the c value. Once I got the c value, I went back to this system and I plugged in the c into the top equation. So I plugged the 5 in for c there, and when I solved, I got an a of 7. Then I worked my way back up to the top, I plugged in an a of 7 and a c of 5, and I solved that equation to get the b value of -6. Again, I'm not going to force students to know how to do that particular method because look at all the work that we had to do. It took up almost half a page worth of work. But I wanted students to see the process, that this is what you do when you have multiple variables that you have to deal with. You deal with 2 at a time, and then you create a new system and you keep using linear combination until you have one variable left.